Now we will see how to use reactive programming in practice. We are going to use RxJS as the tool, which is one of the most popular reactive programming libraries out there. We will build a small piece of user interface. This here is a suggestions box showing a couple of GitHub users that you could follow. It has these features. On startup, it loads accounts from the API and it displays 3 suggestions. Each of these rows is a user with their avatar and their username. And when you click refresh, it should replace these users with more 3 users. And if you click X, then it replaces that user with another suggested user to follow. Let's start with the easiest feature, which is on startup, load 3 user accounts from the backend. Now, this is really just about doing a request, getting a response, and rendering that response. So we need to somehow do that with event streams, and let's just start by representing our requests, which are an event stream of strings. And these strings, I mean the URL of GitHub's user endpoint. But now this is just a stream of strings. It does really nothing. And we need to somehow make something happen when this string is emitted. So we do that by subscribing to that stream, and we get the request URL that the stream emits, and we do something inside here. Now, how do we normally make network requests in JavaScript? Well, one of the options is to use jQuery to get a promise from this URL. So now this will return us a promise, and once you have the promise, you can give a done handler for the response. And now inside here we can, for instance, console log that response. But wait a second, why are we using this way of making network requests if observables can handle asynchronous data streams? Aren't they supposed to already handle this? Why are we using a solution that doesn't look like event streams? So we can try doing this with event streams by creating a response event stream. And the way we do that is by wrapping that promise from jQuery inside an observable, like this. So what we have here is a response stream that will be created from that promise, and now we can subscribe to that response stream and console log that. So if you look at this, it means that the observable can do whatever the promise is doing. So does this mean that a promise is like a simplified version of a observable because you can put one thing in the other? Well, in a way, yeah. Like, promises are basically a simplified version of an event stream that can have only one value or only one event, which is either the resolved value or an error, and they can have only one. So observables go beyond that. They can have, of course, they can have just one event happening on them, but they can also have multiple. So that's why observables are more powerful than promises, because they can have multiple events. So this is pretty nice, and it shows how observables are more powerful. So we still have a problem with our example here because we have a subscribe inside another subscribe, and this kind of reminds us of callback hell. So we don't want to go to that direction, definitely. So how can we solve this? Well, we know that Rx observables have like operators such as map and things like that. So what if we would try mapping the request to the response? That sort of makes some sense. So let's create a response stream that will get that will be this request stream mapped. So it means that we're mapping each of these request URL strings to, well, we need to map it somehow to the response, and the only way that we can get a response is by waiting for that network request to happen. So I just wrote this, but I will explain what it means. Usually we are mapping from a string to a number or a string to an object or something. But now we have to map from a string to something that will happen later in time. So usually we don't map from simple objects and numbers to observables, but this is what we're doing here now. We're mapping to an observable, and this looks a bit different to what you're used to, because this is what the marble diagram would look like. This yellow circle is the request URL string, and it's being mapped to an observable of that response. So this is what we're doing here. So what you get as a result is basically an observable of observables, and we call this sometimes metastream. And you are probably confused right now, and that's okay, because we normally don't work with this, because gladly we have a way of solving this, and that is by calling flat map. And when we call flat map, instead of getting an output that looks like this, we get an output that looks flat like that. So what does flat map do? Well, it basically flattens the metastream that we got as output here after it maps. That's basically what it does. In other words, it's emitting on the trunk stream everything that happens on these branch streams, and then it looks nice. So flat map is kind of like promise.then. You can think of it as like as that. And now that we have this response stream built from the request stream, we can just subscribe to that response stream, and we can put it in the console. And now we have only one subscribe. We don't have that mess of a subscribe inside another subscribe. And this works. And that's part one. Keep on watching, and we're going to see how to build the whole user interface.